So without further ado, let us start our session. Before I delve into the detail, let me have a brief introduction of myself. My name is Yeet Chuan. I'm the CEO of ProtonGlobal Services. It's actually a fully owned subsidiary of Proton Group. I believe most of us have heard about Proton, our national car maker. But PGS is actually a subsidiary just formed 3 years ago by Proton to spearhead Proton's foray into non-core business. Specifically, one of the business that we are in is the new energy business, where we are providing some EE, energy efficiency solution, like LED relamping, magnetic chillers, and so on, and also renewable energy like solar PV system for our plant and also our vendors and dealers. And myself, my background is a mechanical engineer by profession. I was actually posted in overseas for 7 years before Proton recalled me back in 2013. So during the last 10 years, I have been tasked to spearhead Proton's green initiative into this reducing carbon footprint and energy consumption. So we have done various projects, which I will introduce briefly later in our slides. And my journey into energy management actually started 10 years ago. And during that 10 years, we went through a lot of learning, a lot of new knowledge and in this industry, because automotive sector primarily is known to be a pollution, it's a highly polluted sector, because we are making cars that runs on fossil fuel. So today I will share with you some insights on how we can actually address decarbonization of the automotive sector in Malaysia. Okay, I think most of us know what is carbon footprint. It's actually measures to indicate how much greenhouse gas emitted from the company or a country. But does anyone really knows how much carbon footprint automotive sector contributed every year? If you look at the chart here, 76% of the global greenhouse gas emitted is actually carbon dioxide, CO2. And followed by methane, 16%, nitrous oxide, 6%, other gases, 2%. And out of the 76% CO2 emission, 65% actually comes from fossil fuel and industrial processes, including our automotive sector. To put this perspective in terms of numbers, the greenhouse gas emitted globally last year, as of 2022, is 54.6 billion metric ton of CO2. And out of this, about 15.3%, if you look at the pie chart, actually comes from transportation industry, which is our automotive sector. That translates to about 8.35 billion tons of CO2 emission coming from transport sector alone every year. To break it down further, our automotive sector comprises of passenger car, actually the cars that we drive, the motorcycles, the buses and taxis. Those contribute about 45.1%. And the second largest one, of course, will be our commercial vehicle, the trucks, the buses, and lorries that contribute about 29.4%, followed by aviation, the planes, 11.6%, and shipping, the 10.6%, and rail about 1.1%. So you can see if today we are driving a car, a motorcycle, or we're taking a public transport, and also the freight that all contribute about 74.5% actually comes from transport sector alone. And this is actually a very big figure. Then most of you will want to know why automotive industry contributes so much carbon footprint. So if you look at the next slide, this is why. Malaysia, as of last year, we have about a total industry volume, which is actually a combination of new passenger car and commercial vehicle sales alone. We sold about 720,000 cars last year. This is the highest in the last 10 years, if you look from 2013 to 2022. And this year alone, first half, we already sold 336,000. And based on Malaysia Automotive Association MAA forecast, by end of the year, will be similar like last year, 725,000 cars and commercial vehicles sold. So this is one of the reasons why we are polluting a lot to the environment. And if you look at the bar chart on the right, in terms of car CO2 emission, pickup trucks actually contribute the highest. Every pickup truck contribute about 3,510 tons of 10 kgs of CO2 per year per car, followed by large SUV 2,550, sports car 2,460, all the way down to small car like our Produa and Proton car. Every car emits about 1,470 kg of CO2 per year, and this actually is based on annual distance that you drive is only 15,000 km per year. I believe most of us drive maybe more than 15,000 km per year, right? Because per month you probably drive about 2,000 km, so the figures will be higher. And the next slide, if you look at it, Malaysia has about 6.1 million units in operation. What is this UIO means is the vehicle that is 10 years and below that are still running on the road. We only calculate 10 years and below vehicle. Those old vehicle, because not all old vehicle are being recycled. Some are still running on the road. I mean, Malaysia do not have an end-of-life vehicle policy. That's why as of now, 30, 40, 50 years old cars are still running on the road. But if we take only the 10 years and below cars, we have 6.1 million units in operation. And these cars are emitting about 1,515 kg of CO2 per year. That's about 55.4 million. It's actually passenger car. Then we have about 700,000 commercial vehicles, which contribute about 3,510 kg of CO2 per year. And those combined give us 10.5 billion metric ton of CO2 that Malaysia cars are actually churning out every year on the road. I mean, this figure is staggering. I don't know about all of you, but when I look at this, the statistics are quite scary, because that is actually how many tons are 10.5 billion. I just put it into perspective, is about 105,764 KL tower. 100,000 KL tower, we are churning out CO2 every year, ladies and gentlemen. And if you put it into a car, Proton will be launching our new EV. Some advertising here, the smart hashtag one, is about 4.7 million of smart car. 4.7 million, the weight of the CO2 that we are churning out every year. So we know that automotive supply chain is very pollution, but it's also critical, essential for the economy, for all of us in our daily good life. So it accounts about 1/5, about 20% of the global CO2 emission. 3/4 of it come from road transport, as I showed you just now. And our industry now actually is at an important crossroad. Many people, I mean, your friends around you, some may be buying a new EVs, electric vehicles. They are talking about battery EV, plug-in hybrid EV, even fuel cell cars, hydrogen cars, all coming into the market. So to address it further, let's look at how much carbon emission throughout an automotive supply chain. If you look at it, automotive supply chain is quite long. It starts from the raw materials being processed into components and parts being assembled into complete vehicles sold to our consumer like us. We drive it every day until end of life, we dispose it. So there are 3 phases. The production phases actually only constitute 10% of the total carbon footprint of the automotive supply chain. 84%, the big chunk of it, come from the utilization, our daily use of the vehicle, because we are all running on petrol or diesel, which are fossil fuel, right? And only 6% come from the disposal or recycling activity of these cars after the end of life. So now how can we tackle the 84%? And also, don't forgetting the 10, we're also tackling, I will share you in the slides later. Okay, to address how to do this is a very interesting slide, if you want to look at it, because many friends has been asking to me, does the EV really reduce carbon footprint? Okay, so if you look at this slide, actually, if ICE is actually a petrol car, we put it ICE, internal combustion engine. I use a Volkswagen Golf. Why I use a Golf? Because this model are available in petrol, in diesel, and also a full EV variant. So I use the same car to compare. So if you drive a Golf petrol car, you are actually emitting 26,130 tons of CO2 over the lifespan. And out of that, 5,600 is actually from the production of the car. Okay? If you drive a diesel, it's similar, 5,600 from production, but 23,679 tons from the usage of the car. But if today you are driving a full EV variant of the VW Golf, let's say based on California grid, which is boosting one of the highest renewable energy electricity generation of 47.2%, you can see the usage of the red color bar chart actually reduced drastically. Over the lifespan of driving the electric vehicle Golf, you are only polluting only 5,579, much lower. This is because you are using electricity that is generating majority from the renewable sources like solar, hydro, and others. And that's in the grid in California. But if you are on another grid that is very low, majority is still powered by fossil fuel. Example, like the Wyoming grid here, they are only 11.6% from renewable energy. More than 80% are still from fossil fuel, from natural gas, from coal, and so on. So you can see the pollution of the carbon emission during the usage is 24,530, but it's still lower a bit than the petrol, but it doesn't big difference. So that's why I said the grid itself is important to help EV to reduce carbon footprint. Right? EV itself is just running on electricity, but if your electricity are powered by power plants from fossil fuel, I mean in Malaysia our renewable mix for power generation is about 25% only. So that is slightly better than Wyoming, but is far off than California grid. So we can much improve. If we can increase our renewable energy generation from our TMB grid to maybe more than 50%, then the adoption of EV will greatly reduce the carbon footprint. So I hope this explanation can answer whether EV can really help you save carbon footprint. EV alone not enough. You need the renewable energy generation in our electricity grid. That's very important. So if we use more solar panels in our grid, we use more hydro, then we can reduce the carbon footprint. Okay, next. Okay, now I share you a bit on closer to home, our Proton initiative. We actually started our green initiative back in 2014. We have 15 years of CO2 emission reduction plan. The white color one are things that we have done. We started in 2014, where I have actually done a lot of this energy management and EE and RE projects. When over the last 2014 to now, about 9 years, we have saved over 48,276 tons of CO2. How we do that is first we implement energy management system. This is with the support of UNIDO's Industrial Energy Efficiency for Malaysia Manufacturing Sector, the IEE MMS program that started back in 2014 and 2015. So we were trained by our UNIDO trainers from overseas to help us implement energy management system in our plant and our office. Because our trainer said, you can't save what you can't measure. So we learn about how to use EMS system to help us to measure, to set out our baseline. And from then on, we implement our initiative, like low-hanging fruits approach, energy conservation. Example, we change our lights to LED with lamping. We replace our old chiller with a more efficient magnetic chiller. We install oil-free piston compressor at our Tanjung Maning plant. And also we change our CNG gas to LNG gas, LPG gas, which is cheaper. And that itself have really saved us a lot of CO2 and electricity costs. And after we have done our EE initiative, we went on to renewable energy. Back in 2019, Proton started the plan to install our first 12 megawatt peak solar PV farm in Tanjung Maning plant. So we started the commercial operation in May 2021. So we have been running 2 years on the 12 megawatt solar farm that I will show you shortly. And this has saved us over 2 million ringgit per year in electricity bill. Yeah, and the plant can use for 25 years. So now Tanjung Maning plant is actually running on 23% of our energy is actually from renewable energy solar system. And we plan to add on more because we still have a lot of roof and space. Okay. And the next stage, from this year onwards, we are planning to digitalize our energy. What we meant by energy digitalization, traditionally, we only measure, we look at our electricity bill from TMB every month. But that is very old-fashioned because we can only wait once a month to know how much have we spent. So we now want real-time monitoring through apps, through system, software, EMS system that's available on our handphone, on our laptop. So our energy manager and engineers can actually monitor at real time, let's say now, how much electricity that my equipment are using. Is there any irregularity, any spike, or even after office hours, operator forgot to switch on the machine, we will know immediately and we can act on it instead of waiting until end of the month for the bill. So these are the things that we want to digitalize all our energy data on the screen. And of course, launching of our new smart car in shortly this year, Proton will be launching our first EV, the Smart #1, by end of the year. So this will also help to address the usage in the carbon footprint I mentioned just now in the automotive sector. And moving forward, in our few years, in 2024 next year, we are planning to roll out the second phase. We'll add on another 4 megawatt of solar farm in our rooftop. We also want to introduce battery energy storage system. And we're also planning to consolidate our 2 plants from Shah Alam and Tanjung Maling into 1 plant for increasing the operational efficiency as well as reducing the energy costs. And finally, in the not the distant future, by 2028, we hope to construct our own cogeneration plant where we can use natural gas and generate electricity and heat that we can use for our production processes. And we will add on the 3rd phase of our solar PV, another 4 megawatt. So not just in our plant that we have introduced the decarbonization initiative, we also start with decarbonization of our Proton dealers, our vendors. As a result of the solar PV system that we installed at our plant, we've seen the big saving, and that's why we encourage our dealers to put on a lot of these solar panels on the rooftop. If you go around Malaysia, you will see a lot of Proton big 4S and 3S centers, right, selling cars, the showroom. So the rooftop, one by one, they are installing solar. As of date, we have 10 dealers that have already installed, as you've seen the photos, some of them, and many more will come. We hope to achieve this figure of about 50 dealers to install the solar panels by next year, and also bringing in the vendors as well. Okay. Now for the next part, I will share some real-life case study that we have went through so that we can share with our automotive peers and partners to how we all can play a part in the decarbonization journey for automotive industry. And of course, end of the day, there's also a cost saving to justify the investment from a financial standpoint. Okay, next. Okay, the first thing that we have done is we've come up with a sustainable building features. As you can see in the red thing, we highlight here, we have high performance glass that we ask the dealers to install. What we meant by this is a lot of the showroom are actually glass so that you can see the cars inside and it's look more modern. But does you know that actually the sun, which carries the heat, is the infrared, can penetrate all this glass, and it can increase the temperature inside the building by at least 3 to 5 degrees. And this will cost more electricity because your aircon needs to work harder to bring down the temperature to a comfort level of 24 degrees. So by having high performance glass, it actually has a vacuum inside that it can act as an insulation. It can reduce the indoor room temperature by at least 3 degrees Celsius. By reducing 3 degrees Celsius of indoor air temperature, we can actually reduce 7% of aircon cost, which actually constitutes 60% of a building. 60% of a building cost normally is from air conditioning. So this will reduce the aircon cost. And we also install high efficiency, variable speed, this aircon. That is a very good centralized aircon. You can use variable speed so that when there's less people in the building, it will automatically run slower, generating less chill water, and it can reduce less energy consumption. We also install efficient smart lighting. Besides changing the LED, we put sensors so that when there's no occupant around in the room, it will automatically shut off. So these are all smart lighting sensors we can put. We also insulate the roof because solar infrared doesn't just come through the glass, it also comes through the building and the walls. So we insulate it, and we install solar panels as you shown earlier to generate electricity from renewables. And natural lighting is important because when you design a building, if you don't have any natural lighting, you are depending on lighting, so you are consuming electricity. But in our production plant and in some of the showroom, we actually let a lot of daylight harvesting so that the natural light can come in. So during daylight, with daytime, we don't need to switch on the lights. Only during rainy day or nighttime, only we switch on the lights. And you must also monitor your energy closely so that I mentioned just now the digitalization of energy so that you can react in case there is any machine that is not shut off and so on after office hour, you'll know. And in our workshop, we also put in natural ventilation. We put in vacuum fan that we can actually suck out the hot air that is accumulated in the workshop and replace with the cold air from outside. Okay, so we hope that to implement all this in our dealership in stages. Next. So the next is our HQ. This is actual office Proton HQ in the Kesas Highway, just beside Kesas Highway, the glass building there. If you look at the electricity bill in 2015, we are having a 6.7 million kilowatt hour where you consume. The bill was 3 million ringgit a year. But if you look at the last 8 years, we managed to reduce it to 3.5 million kilowatt hour or about 1.8 million ringgit a year. This is the same building, same number of employees. It's not production related. So the rest of the variable are same. Our working hours still same, 8 to 5:30. But we managed to cut down 47% in energy usage. And we save about 2,360 tons of CO2. And in ringgit, it's about 1.2 million saving. So many people ask me, what did I do on this, right? Actually, we started in 2015 without any budget. That time, Proton is not doing so well. So we are struggling with high costs. So we do not have any budget. But that do not deter us from doing something on reducing energy, reducing carbon footprint. What we do is, we went through a walkthrough audit of the whole office. We identified wastages. We noticed that our aircon are so cold that all of us have to put on jacket. It has sometimes it's either set at 16 degrees, 18 degrees. But actually, based on government's statistic, the comfortable level is actually 24 degrees Celsius for indoor. So you feel comfortable without wearing a jacket. So therefore, we increase our temperature slowly. We do not go from 16 to 24. A lot of people will complain. Especially coming in from outside. So we do it 2 degrees by a time, and then after a few weeks when they adjusted, we increase further until we are now about 23, 24 degrees. And that itself saves you a lot of money. And also our office start working at 8 o'clock to 5:30. But over the night where there's no aircon, a hot, stuffy air inside can go up to 30 degrees Celsius. So we start running our centralized aircon by 7 a.m. to have 1 hour to cool down the office building before we come to work, so we all feel comfortable. And we off it only at 7 p.m. because after 5:30 there's still some people in the office. But I feel that is very wasting. So what I did is I don't on our centralized aircon at 7. I switch on our air handling unit, actually the fan, which can suck out the hot air that accumulate overnight. I start at 7 a.m. until 7:30. It suck out the hot air. When it suck out the hot air, it replaced with the cool morning air inside, which is 25 degrees Celsius. So it lowered the internal temperature from 30 degrees to 27 degrees. Then only I on my centralized aircon at 7:30 instead of 7 o'clock. And because the temperature gap is lower, so it just need to cool down from 27 to 24. But before that, you have to cool down from 30 degrees to 24. So I save a lot of electricity by that. And then after a whole day, I only off my aircon at 5:30. I don't off at 7 o'clock. Why? Because over a whole day of cooling, there's still residual cooling. I off my aircon, but I still maintain the fan running, the AHU fan. So there's aircon circulating, cool air circulating. So only after 1 hour, the temperature will slowly goes up. But by that time, after 5:30 to 6:30, most of the employees have already left for home. So they do not notice the differences. Yeah, I save a lot by just changing the operation on and off time. Yeah. So those are the no-cost, actually low-hanging fruit that any one of us can do in our office building, in our production plant. And it doesn't involve cost. Just changing your, optimizing your control. Yeah. And beside that, what we did also, we know that our lighting, street lighting at our employee car park, there's a lot at night. It's all very bright lit. But most of the time at night, there's nobody there. So what we do is, we delamp one of it. Every street light, we have 2 light bulbs. We take out 1 light bulb. We only left the perimeter for safety reason. The internal one, we delamp 1. There's still sufficient lighting, but not. We can save a lot on that. And also, we have a billboard that runs on the light from 8 p.m. to 7 a.m. In the morning. By now, I set timer. After midnight, I off it because there's nobody running on the Kesas Highway on the midnight. So I don't need to have the advertising board on. So I set a timer. So all these small things that we have done has saved us from 6.7 million kilowatt to about 5 million. Then after we save those money, what we do is we invest to do LED relamping. We change even a chiller. That's why you can see from 2019 onwards, it dropped from 5 million, 4.3 to 3.6 million because I changed chiller, I changed LED lamping. So it's safer, it's cheaper also. And also I can change tariff also. Most of us doesn't know actually TMB, when you look at your electricity bill for your office and your production plant, if commercial you have a C, C1, C2, C3, industrial is E1, E2, E3, you can actually change your tariff by writing into TMB. Many people doesn't know that. Home cannot, home is just a A. So, but commercial industry, you can. So I changed our tariff for this HQ from C2 to C1. Why I do that? Because C2 tariff have a maximum demand penalty of 45 ringgit per kilowatt. C1 only have a maximum demand penalty of 30 ringgit 30 cents per kilowatt. So I save per kilowatt 15 ringgit. This COE maximum demand is about 1,000 over kilowatt. Right. So immediately I save more than 20,000 a month just by changing tariff. And that doesn't cost you a lot, just cost you a one-time fee for TNB to come to recalibrate your meter. And it can be done, even if you want to change back later, the tariff you can. So these are the things that you don't need big money to invest. You should actually ask your engineers to study if your production plant, your office building, which tariff is the best, it is lowest. Because each tariff, they have different maximum demand and different peak and off peak. So you have to, based on your own demand, you do a calculation, simulate it first, then you can apply to TNB. Okay. Then finally, now we have reached about saturation about 3.5 million kilowatt hour per year. Yeah. Actually, we can go further. What we can do is we can install solar. If we want, we can install solar on the rooftop. We can further reduce further. Okay. So this is not magic. This is just science. Pure science. Very simple thing. So I think everyone can do. Yeah. Thanks. Okay. This is the 12 megawatt peak solar farm in Proton Tanjung Malim plant. The one that you see here is our first and biggest solar car park in Malaysia. This is a 9 megawatt bifacial solar panel. Bifacial means they actually have two sides, the solar panel. Most of the solar panel is one side. The sun hits the first side, it generates electricity, but that's all. But what we do here is, because we park our car underneath, when we produce our finished car before shipping out, we park it at the car park here, we park below. So when the sunlight hit the car body, it reflects back up. So I don't want to waste the reflected solar energy. I have two sides. My solar panel is bifacial. So it actually increased 10% yield compared to a normal solar panel. So I can generate more electricity. So this is good for car park. You can actually use bifacial. Nowadays, bifacial is very common. You can use, back in 2021, I think we were one of the first to use bifacial solar for car park. So this is the biggest 9 megawatt. We have another 3 megawatt on our rooftop. So bringing it to 12 megawatt. And started in May 2021. So far, we have reduced 27,447 CO2, tons of CO2. And over 25 years, our forecast saving from this project is 65 million ringgit. So we have been seeing the actual generation for the last 2 years. In fact, they are generating more than what we predicted on paper. So the sun irradiance in Malaysia is quite good, actually, especially the northern states like Kelantan and Kedah. So you should actually put in more solar, whether it's on your rooftop, your office, or your factories. Yeah. Okay, next. We also done a lot of energy efficiency. We call it EE initiative. We get our engineers certified as a registered electrical energy manager by Suruhanjaya Tenaga, so that we can actually do energy saving in our own plant without hiring third party. That saves us a lot of cost. And also we done a lot of awareness campaign, the campaign Hijau in hanging up banting banners to bring awareness, because awareness is the first thing in carbon reduction, I think, because we need to be aware of what we are wasting. We are polluting the world, so we need to know that. And we also share our experience in a lot of forums. And our engineers, if you look at the energy team, they go around our workshop, identifying compressed air leakages, identifying other leakages, so that we can rectify it. So these are very important. Compressed air is one of the biggest energy user in the plant, also in the workshop. When you walk around, you'll hear a hissing sound, all this, during lunchtime, that is leakages. And when you compress the air, as a compressed air, you use a lot of electricity. But then because of the hose coupling leaking, you let it leak out, it's all wastages. And those are artificial demand that you don't know. And you keep on churning more compressed air, and that is wastages. So the first thing you do is to do an air leak audit. Have a team dedicated, walk around your plant. You don't need very sophisticated tool. Of course, we have the tool, ultrasonic, but you don't need to buy it. You can actually go around during lunchtime break. You can hear the hissing sound, then you go and identify. You can even use soap with water to wipe a gauze to see where got air bubbles. That one costs you not much money. And you will identify the leakages. You just change the coupling, change the hose. Usually those are the area where you have leakages. Once you plug all the leakages, you will immediately notice your compressed air demand drop a lot. And then you can use less compressed air. You can even shut off one compressor. And one compressor 1 year actually use about 1 million ringgit electricity bill for those big compressor, commercial grade. Yeah. So these are the things that we have done in our plant. Okay, next. Okay. Next, I want to share with you some of the new technologies that we are trying to find. Because as we journey further, in order to reduce energy more, we need a higher level of technology. So we went to China, went to overseas to see. So some of the future EE and RE technologies. First, I want to like to share is actually a thing called battery energy storage system. In short, we call it BESS. In layman term, it's actually a big power bank. How big is big? For industrial gate, it can be as big as a 40-footer container, like this one. It can be multiple 10, 20, 40-footer container for an automotive plant. So what we do is we charge the battery at night, meaning doing the off-peak demand from 10 p.m. to 8 a.m., where the tariff is the lowest for industry. Then we discharge it at the daytime peak period between 8 a.m. and 10 p.m. That's where TNB charges maximum demand and the peak tariff. So by doing that, we can reduce our energy cost because we charge at low peak and off peak. There's a differential cost, and we can reduce maximum demand, which is very high. So these are the things that battery can help you. And if you have a solar plant like us, like the 12 megawatt solar plant, you can link it to the battery so that if daytime your production is not a lot, you generate more excess electricity, you can actually store it in the battery bank. You can use it for nighttime operation, your lighting and so on. Yeah, so battery act as a power bank and also act to give out electricity. If you got surplus, let's say with Saturday, Sunday, our plant not working, so you got excess capacity, what you do, you can actually export back to the grid also. So it can help the grid in terms of stability. Because the grid nowadays, you have a lot of large-scale solar farm. There's this thing called intermittency. Intermittency means the power from the electricity generated from the solar farm is not stable because there's a weather condition. You have rainy day, you have cloudy day, that we have a drop in the electricity generated. Once you have a drop and your power grid relies a lot on large-scale solar farm, you will have this grid instability. So battery can resolve this. It can instantaneously pump out the power needed to maintain grid stability. Singapore has done it. They have and Sembcorp have actually put in Southeast Asia largest BESS system, 146 megawatt hour on the Jurong Industrial Park. I just visited last month. You can look at it. They use it for grid stability. At any one point, the TNB grid Singapore grid will ask the Sembcorp to pump up 100 megawatt hour of electricity within seconds. Yeah. So that is one of the things that we can consider best. It's very common in China also. A lot of industries, factories, or even household, they have this smaller battery system. Especially nowadays in Europe, because of the Ukraine war, energy cost is rising, and during winter, they need cooling. So they actually buy battery bank to store electricity. Then they can use it to power their heater. So it's very sellable now. Household power bank, we call it. So in Malaysia, maybe we don't need a household, but we can definitely use it for factory. Next, I'll show you how the BESS can also save MD. If you look at this chart, the red color one is the nighttime, where I mentioned we charge it, the red portion, the battery, that's the BESS. And then we discharge it during the peak at let's say around 12 p.m., the blue color portion. So by discharging it during the peak, my energy demand, the dotted line actually become flat. So I shave the peak, the two peak, the three blue color peak, I shave it. So when I shift it, I reduce my maximum demand. So TNB charge me less on MD. And this MD, just for information, a plant the size of Proton in Tanjung Malim, we are paying 500,000 maximum demand charges every month. By putting in a 4 megawatt hour one, I can actually save 1 million a year, just on maximum demand. And my battery cost me, let's say, about 6.45 million for a 4 megawatt hour battery. So my payback about 6 years ROI. Based on the LFP. And nowadays, battery are very long life cycle. It can go up to 6,000 cycles, can last me 16 years because I only charge and discharge one cycle a day. 1 year, 365 days. So 6,000 cycles is 16 years. So it's a worthwhile ROI to consider for maximum demand. Another one I want to introduce is on the vehicle to grid. What we mean is vehicle to grid is EVs are getting more and more popular. Maybe not so much in Malaysia, but we are picking up pace. In Thailand, in China especially, there's thousands and thousands of EVs, even millions. So imagine all these EV, if they are charged during the night time at home, when they go to the office or go to their workplace at the production plant, let's say we have Proton, we got 8,000 employees. Each one of them drive an EV and park about 5 to 8 hours a day when they go to the office and the plant to work. All these EV are a minor power bank, mini power bank. Imagine they're all plugged into the vehicle to grid. The power can go back to the plant to tackle our maximum demand and electricity. And end of the day, before go back to work, doing off-peak time, we charge back the EV. Or we can give the employee some token That's for you to help us, mini power bank. I mean, this is not just for the own plant. I mean, for government, for highway. If there's, in future, it's all the cars that we say, the 6.1 million unit in our circulation all become EV. You can do this vehicle to grid. It can solve a lot of issues. So you can plug to the system, you can charge both ways. That's why the vehicle can charge the grid can charge back to the vehicle. So these are the technologies that are already available. And we can also use second-hand lithium-ion battery from industrial grade, like from container. We can also store it and charge back to the grid. And also new power, the power battery that powered EV for 8 years. After 8 years, they always go for recycling. But the battery degradation is not the same for every battery. Some battery, it may not be sufficient to power an electric vehicle because of the weight and the speed, but it is very sufficient to power a house. So we can actually harness some of the lithium-ion battery, use one second-hand, make it into a smaller household battery to use for household, or we can actually give it a second life, we call it as a battery recycle for the solar street light. Malaysia have a lot of street light, but I don't think we have a lot of solar street light. So we should actually put solar street light because you don't need TMB connection already. In new area also, you don't need to lay cable. Cable is very expensive, right? And you need to maintain. So you use a solar street light, you use a small battery to store the electricity that the solar panel generates so that at night, the electricity from the battery can power your LED light, street light. And they can use a recycled street light from the EV battery. This is not a new thing. In Japan, Nissan Leaf, if you look at the small photo, the Japanese guy there, they have this project called the Reborn Light. If you Google Reborn Light, what they do is Nissan Leaf, the old Nissan Leaf battery, they actually collected back because Leaf have been selling around I think more than 10 years. So a lot of the battery are old already. They just collect it back, they break it down into smaller one. They power the entire city's solar street light. So this is no cost because you take back things that is already going to the garbage. So you take it back, recycle, reborn it, and then you can use. So that is one of the things that we think our government can, or private industry also can do. Right? Okay, next. So first thing is I also want to talk about our energy roadmap. We need to have energy roadmap because on AI and digitalization is very important. I mentioned just now energy digitalization. So we can achieve higher energy costs. What I mean by digitalization is when we, in 2020 to 2023, when we've done all the things I mentioned just now with solar, LED, and so on, we need real-time analysis. So now we are putting in sensors that give us feedback on the real-time energy pattern. And the AI will alert us if there's energy wastages. We can set a threshold. If the energy increase more than the threshold, it will notify the energy manager so we can take our action. And the profit generated from this can also be sell back to the grid. So we reduce immediate wastages. Example is during MCO time in the last 2 years, because we have a monitoring dashboard while we are at home. We monitor, we notice one of our plant, the furnace forgot to switch off. So we quickly alert the emergency maintenance guy there to switch it off. And we save over 3 months of MCO, thousands of ringgit. If imagine we don't have this real-time monitoring, we will only know it when we receive the TMB bill. So these are things that we saw that has been shown that can save money. And people make mistake. People being, not with they say people are lazy, people are forgetful. Sometimes we forget to check every now and then. But AI, the computer will be always there, 24 hours round the clock. So if we feed them enough data, they can analyze the energy efficiency. They can actually give us predictive. They can predict our energy usage based on our production volume, based on our number of people, based on our pattern, and they will let us know what sort of energy demand your equipment, this size of plant or office will need. So if our actual demand above the expected, we know we have wastages. So the AI can help us to identify the gap and we can address it. In the future, if AI is smart enough with enough data, they can even prescribe to us what we need to do. That's something in the science fiction, but the development of the industry IoT is towards that area. So we hope that we can use some of this use case in our industry. Next. Okay. Lastly, before I end my slide, my presentation today, my 3 steps easy to decarbonize. First is you must set a goal, a target. How much percentage of kilowatt hour or how many tons of CO2 or how many ringgit you want to save. Just set a goal. So when you have a baseline, you can set your goal. And based on our experience, low cost, low hanging fruit approach can easily save 10% to 15%. These are based on our experience. Then when you go to EE, it gives you 20 to 30 to even to 40%. But when you go to RE, it can give you more than that. But RE is very expensive to invest. So start from small first. Set a goal, start from small. And the second very important thing, you must secure your top management commitment. Your top bosses must buy in. Because energy saving sometimes may not be the main agenda of most company. Profit, yes. But if you can tie their profit bottom line to energy saving, then you're likely easier to get a buy-in. Because you need top management commitment to push all your energy efficiency EE, RE projects. So that's very important, okay? And lastly, just do it. Don't stop because you have budget issues, you don't have know-how and so on. We started from not knowing anything on energy, but we went for courses, trainings available. We also get third party to invest. Our first 3 projects are in Proton that I mentioned, the LED, the chiller and the air compressor. We use zero capex. We doesn't spend a single cent because we don't have the funding that time. We get third party to invest in the equipment, put it at our plant, and then every month from the saving from TNB bill, we profit share with them. Of course, they invest, they take maybe 80, 90%, we take 10 to 20%, but it's still good. You can still get something. So there is a lot of these EPC companies, third party, they are willing to invest into RE and EE asset. So no budget or no money to invest doesn't stop you from energy saving. That's my advice. And next, just use the step 1, use the ISO 50001, the energy management system, which we have actually do. It's a very simple PDCA. Everyone knows it. You plan, you do, you study, and you act on it. So planning is where I mentioned just now. You set your target, you set your goals, and you must have an energy policy. And then you put in resources, manpower to do it. Then you do training. You need to know what to do. And communication to awareness and so on. You set in control for your equipment and system. And then you start checking the result, corrective and preventive, and do internal energy audits. And finally, management review. So this is a cycle that you continue to do. It's very simple too, but effective. Next. This is a policy, green policy that we launched in September 2015. So we commit to comply with all the legal requirements to reduce our vehicle emission, fuel consumption. Now we are doing EV, which is in line with that. And we reduce our plant energy consumption and also improve operational energy efficiency on a continuous basis. We do it every year. Every year we set a target. Of course, the first few years will be high. As you go along, the target is getting tougher and tougher to save because all the low-hanging fruit have been harvested. So we are now setting maybe every year 3 to 5% we can reduce. But first 5 to 10 years, you can show we can reduce more than 40%. Yeah, and reduce waste. You must reduce waste. And also promote new technology that I mentioned just now. We continue to learn from overseas what people are doing in the advanced country. We bring back the technology, we implement. So those are promoting in green technology. Not just for our own, we also encourage our vendors, our dealers to do it, to implement it as well. We recommend the same supplier that can do this. And finally, do the whole ecosystem because automotive, like I mentioned, is a long supply chain. You need everyone to do, not just Proton alone doing or Prodo alone doing. You need your vendors, your suppliers to all chip in. Okay. Lastly, we set up a green wheel, which is actually, this is the green wheel, sorry. Phase 1, we done the EMS system. Phase 2, we do energy efficiency. Phase 3, we do the waste and water management. Phase 4, we are renewable energy. And now we are at Phase 5, which is energy digitalization. At the center is always to reduce carbon footprint. Okay. And please update your roadmap from time to time. This is our roadmap from 2015 to 2023. And now we have a new roadmap, the 10 years plan from 2017 to 2027. So continuously upgrading your roadmap based on the new technology. That is also a key. Okay, I think with that, I would just want to end my presentation. Before that, I think sustainability starts from every one of us. So we all have a part to play, whether in our organization, our company, or at home. Okay, thank you very much. Thank you. We still have time for Q&A, right? Any question? Yes. Yes. The mic.
Hello. Yeah, thank you, Mr. Lee, for the presentation. Very insightful. I got 2 questions. Number 1, I'm not sure whether you'll be able to answer, but using your mechanical engineer background and also being an auto player, for companies, car dealers, right, the likes of Auto Bavaria,
Mm-hmm.
Burmas,
Mm-hmm.
who don't manufacture the car, but they sell the cars.
Mm-hmm.
When they sell cars and things like that, do they have carbon footprint in that sense? Do they need to measure and also reduce that carbon footprint if they are selling ICE cars, right?
Yes.
Okay, that's first question. The second question is, it's interesting. Just now you mentioned about environmental friendly cars as a result EV, but you were concentrating more on the production of it using electricity.
Yes.
One of the criticism of electric vehicles is the battery, especially the BEV, right? The lithiums and everything. Yes, you need to do a lot of mining.
Yes.
How does this come into play where you also need to reduce mining, which is very, very toxic and also very environmental unfriendly? Do you have any statistics to show where this fits into the whole ecosystem in terms of carbon reduction? Thank you.
Okay. Thank you for two good questions. The first one, as a distributor, actually, if you look at the carbon footprint chain, you can go back to the slide. There's production is 10% of phases, right? And then usage is 84%, and finally recycling is 6%. So in the production, actually, there is a phase where we distribute the car. So you only see the vehicles complete coming out of the factory, right? So the factory from the vehicle, they have to ship it to the dealers, the motor pool, and then they distribute to the showroom. So that itself also emits carbon footprint because you use lorry, you use car carrier to move around. So those are still running on diesel, fossil fuel. So they are carbon footprint. So they can actually measure their carbon footprint. Regardless of it's a EV or it's a ICE engine car, by shipping using petrol-powered or diesel-powered car carrier, you already have carbon emission. So basically, they can measure for every kilometer how much the carbon footprint they actually measure. They can do it. Our parent company, DRB Hycom, actually also measure their scope 2 and 3 carbon footprint, and it involves distribution of cars also. So there is in terms of transportation. Yeah. Yeah. Yes. Yeah. They should, because beside the transportation, they also have showroom, right? I mentioned just now the showroom. They have lighting, they have air cons. So those are also generating carbon footprint. That's why we encourage our dealer to install solar, to do all this LED, high performance glass, everything. So they are actually generating carbon footprint without them knowing it. We can show statistic of one dealership. Example, a dealership mid-size, if they occupy a 1 acre land, they probably they will spend about 10 to 20,000 ringgit a month on bill. 1 year is also few hundred thousand. So they generate few thousand tons of CO2 also. If they have 100 dealership, that's a lot. So they should do. Yeah. Okay, on the second question, on battery, of course we know the battery mining and shipment of all this raw material is damaging. It's actually producing carbon footprint. One of the ways to tackle, I don't have the statistics with me right now, but one of the ways that tackle is having a circular economy. In China, the first batch of EV was launched somewhere in 2014, So their cars now, the battery are near the end of life, 8 years to 10 years. So they are going for recycling. So what they do is they take back the power battery from the EV. They try to harness those good cells that can still use for the second life, like I mentioned, for solar street light or other thing. Those that cannot, they will grind it into the powder. They will use this hydrometallurgy process to filter it out back to the original powder form, like lithium, cobalt, manganese, and other minerals. And those can be sold back to the battery maker to rebuild into new battery. So they are doing that in a big scale in China. Even Korea there's Korean company in Malaysia already set up just to collect all the old hybrid EV battery. And also not just from car, our cellular phone, our handphone, our laptop are using lithium-ion battery as well. So those e-waste actually can be recycled back to powder form and sell back to make into new batteries. So this is a way we call this term called urban mining. Instead of actual mining, few thousand kilometers away, you can do urban mining. From the city, you collect all this used battery, and then you mine it, and then you bake it into powder, you can sell it back. This is actually a profitable business. There's a lot of players now into Malaysia. They are trying to set up this recycling for batteries. Yeah. Okay. Yes. Yes. At the moment, we are starting with our own plant because out of the 10%, mostly is yes, suppliers, including in the 10%, including our own plant. So we are doing our own scope 3 and scope 2. Later on next year, maybe we will ask, we want to formulate something called green procurement, make it into a procurement policy that whichever vendor you want to do business with us, you have to have some carbon footprint reduction. Right, you must have your carbon emission measured and how much you can save. So something like that. Because if we now talk to them about doing all this energy initiative, they will not be interested. It's not so easy. Yes. So we want to slowly put it into the green community, and we study ourselves first. Then we invite our supplier. You come to our plant. Because our plant got the equipment, their plant also have. We have chillers, they have chiller, we have compressor, pumps, they also have. And we show them by doing this, we save so much. So we can share our knowledge with you. We can send our engineers there to coach your engineers to save it. And then we help you to reduce your utility costs. In the end of the day, reduce your manufacturing costs. And then when they see that, they are more willing to open up. Okay. Yes, the lady there.
Actually, the question was quite similar to your scope 3 because I understand one of the biggest challenges for a automotive industry is to reduce scope 3 emissions. And I recall I was wondering how can we reduce emissions from the usage side when the car goes to the customer, is in the customer's hands. Do you have any suggestions or feedback on that front?
I mean, one of it is to encourage them to buy an EV lah. But that one is the Malaysia grid need to be greener lah, in terms of the IE grid. Because if your Malaysian grid is still powered majority by fossil fuel, I mean, it does not help lah. Yeah. So how to teach customer to reduce carbon footprint? That is a tough question. Unfortunately, I don't have a solution now. But I think driving an EV is a first step lah, because it doesn't use the petrol directly. Another way maybe to teach them not to speeding, because drive at a constant speed, it actually save fuel consumption or save electricity, so it actually reduce carbon footprint.
Hi, my name is Pauline. I'm interested in the BESS system that you mentioned just now, the battery storage system. Is that a CAPEX model or it's an OPEX model? And how much actually, all this excess energy that you store in the battery, how long can it last? Or, it does not matter, it can actually last perpetually, whatever energy that you store in this system.
Okay.
Thank you.
Okay. So the best nowadays are majority lithium iron phosphate LFP batteries. So their life cycle can go between 6,000 here to maximum 10,000. So what they do is, you charge the battery. Let's say you have a 1 megawatt hour battery. You charge it 1 megawatt hour, okay, until 100% SOC. Then when you discharge it, you don't actually discharge it to zero. There's a usable energy you can discharge, maybe about 85% to 90%. Because it's not good for you to discharge it to zero. Then you charge it back to 100. That will shorten the battery life cycle. We all know that even you drive an EV or using your handphone, don't deplete your battery until zero. So always leave a SOC maybe about 10 to 15%. Then you charge it back. And then that is one of the ways to prolong the life cycle of battery. And the model actually nowadays we are looking at CAPEX is one model. And another one, OPEX also, there are companies, best company, manufacturer in China, they are approaching us. They are willing to invest if the ROI and the client is a good, credible client. They are willing to invest and they profit share with you. Let's say they sign a 10 years contract with you. Over these 10 years, they guaranteed minimum energy output from the battery. So all the operation maintenance and the initial investment cost on them. Then every month you save on your MD, on your electricity cost. The profit sharing, maybe we can discuss. They maybe take 80, 85, you take 10 to 15%, something like that. So they are okay with the OPEX model also. So they are both model. Yeah. Typically now most of the battery comes from China. Japan also have, Korea have. Samsung SDI is also experiencing with TMBR. Yeah. So in terms of cost, of course, China has a lower cost for batteries. Typically now ROI we calculated is about 6 to 7 years. Because that's the two reasons. One, because it's our Malaysia, our peak and off-peak tariff, the difference is not a lot. Example, for Proton, we use E2 tariff industry. Our peak is 35.5 cents per kilowatt hour. Off-peak is 21.9 cents. So the difference is less than 14 cents. So it do not save a lot. What we can recover the investment is from the maximum demand saving. Our maximum demand is 37 ringgit per kilowatt. So Proton Tanjung Maling, we have about 15,000 kilowatt MD. So 1 month we pay about 500 over 1,000. So there we can save a lot. But in China it's different. In China, the peak, they have peak, super peak and off-peak. So the super peak and peak difference with off-peak can be more than 1 renminbi, 1.2 renminbi per kilowatt hour. And because of that big difference, the best ROI can be shortened to 3 years or 2 years plus. So that itself why the industry is booming, because of the big gap. Their government encourage industry not to use the electricity at peak. Try to shift it to the off-peak, the night time. Yeah. So they give a big gap difference. They are similar technology. Battery cells is similar. The battery I mentioned, LFP is the safest battery to use. Instead of NCM, the rest, they're using LFP for energy storage purposes. Life cycle is more or less the same, but it also depends from manufacturer to manufacturer, and also depends on how you use it and the operating condition, whether it's very dusty, it's very hot, humid. All these play some factors. And also the BMS system is very important, the battery management system. If you have pack level or rack level monitoring system, every time you charge and discharge, the chemical reaction in the battery will cause fluctuation, even very minor current and voltage discrepancy between cell. So you need to do SOC calibration. So a lot of the technology doesn't do SOC calibration every time. But I think Huawei and some of them, they actually do SOC calibration every time they charge and discharge. So they maintain the consistency of the voltage and current among the battery cell. So it do not degrade so fast. Because battery actually degrade, like solar panel all degrade, maybe average about 1.5 to 2% every year. First year will be more, then second year is slowly about 1.5 to 2%. So over 10 years, you can expect your SOC will reduce from 100 to 80%. So anything above 70 is still acceptable over the lifespan of 10 to 15 years. Yeah. But the battery I mentioned you can use for 16 years, just that you don't have the initial capacity. Like I mentioned, if you start with 1 megawatt hour, maybe after 10 years you are left with 0.8, 0.7 megawatt hour, but you still can use it. And I believe in after 10 years, the battery cost will have come down because more and more people use it, economy of scale. So you can also top up. You can top up new BESS system, new battery cell, to complement so that you still get your 1 megawatt hour output. Nothing. Any question more? Any more question? Okay. In that case, I thank everyone, and I thank you to Datin Sri Sunita and CGM for giving me the opportunity to speak here and share some of my knowledge. Thank you very much.